Alright, so let's go ahead and go over the warm-up for today. Should be review stuff that you guys did really well with this on your final exam, so I'm not too concerned that you had trouble with this. Y intercepts at 5, down 9 over 5. Going to be dotted or solid? Dotted. Alright. And are we shading above or below? Below. It is less than, so we want to shade everything over here. And just a reminder on ECA, you'll have some buttons. So you'll have something over here that says like line. There's a button. And then one that says dotted. And there's a button. And then another one that says shade. So you would hit, and we'll practice this before we actually take the test, but you would hit the dotted line once you've made your 2 points. It'll draw that in for you, and then when you hit the shade, you just click on whichever side you want it to shade, and it will shade for you. Okay. But again, we'll practice that, so you shouldn't have any issues with that at the time. That would also be something that as we're taking the test, if you're having trouble with that, that's something you can ask. Like, you can't ask me if it's a dotted or a solid line. But if you call me over and say, I want it to be dotted and I can't get it to be dotted, that I can help you with. Okay, so don't miss a question because you're having technical difficulties. Make sure you ask if you have that, okay? All right, second one. Again, another type of problem that we did really well on your final exam, so we'll cross multiply. So we got 8 times x minus 1 equals 6x. Removing parentheses, we get 8x minus 8 equals 6x. Variables on both sides, so hopefully you brought them over to the same side. And again, if yours is slightly backwards from mine, we should end up at the same place. What's 6x and negative 8x? Negative 2x. Divide, and we get positive 4. Again, if you didn't have either one of those, make the corrections so that as we see those problems in the future, we'll have a good example to look at. Those are definitely 2 problems that you'll see on ECA. Again, I think those will be easy points for you. So you'll want to make sure that you get those right. All right, let's do a little bowling. Feels like we haven't bowled for a while. You'll notice our bowling has changed slightly. There it is. All right. Let's have orange bowl first. 5. All right. Pink. Go next. 4. And finally, it bounced next. 4. Okay. And as we've done before, you also have a 0 that you can use at any point along the way. You got a couple 4s there, so you can also take square roots. All right, so we got to get 1 through 10, but then we also need negative 1 through negative 5. So you have to work a little bit to see if you can figure out how to get those. All right?
What's the 0 again?
0, you can multiply it to get 0, or if you take it to the 0 power, it equals 1. Yep. All right, who's going to start us off?
Me. 5 minus 4 equals 1 minus 4 is negative 3.
Nice work getting the negative right from that. All right, Sierra?
4 minus 4 minus 5 is negative.
Very nice. 4 minus 4 minus 5 is negative 5. All right, kid.
4, 0 to the 4.
4 to the 0.
4 to the 0, and then 4 plus 1 is 5, and 5 plus 5 is 10.
Very nice. All right. 4 times 0, you said? Perfect, yes. I just couldn't hear the first part of it. All right, Maddie?
5 times 4 is 20, divided by 4 is 5.
All right.
Wait, no. Yeah, 4 plus 4 is 8, and then 8 minus 5 is 3.
Just do yours. Don't forget you can take the square roots of those, so you've got some change there also that might be helpful. So lots more you can get. Sierra?
Before I had
To the 0 power?
no,
Oh, square root.
zero.
Yeah.
And then plus 4, and then 6 minus 5.
Very nice. You got another one, Kaylee?
5 and 0 was how do we say it? And then 4 plus 4 is 8, and 8 times 1 is 2.
Alright. You got another one?
5 plus 4 is 8, and then 5 to the 0 power, and then 8 plus 1 is 9.
Nice. And another one?
4 plus 4 is 8, and then 5 to the 0 power, and then 8 minus 1 is 7.
Very nice. I was hoping you'd catch on to all 3 of those. Alright, so lots more we can get. We can definitely get 4, we can get 6. 5 Catch up with you. Alright, Michaela?
5 plus 4 is 9, times 0 plus 4 is 1.
That would work. Kayla?
Okay, 5 minus 4 is 1, and then square root 4 is 2 times 1 is 3.
Very nice. Alright, Tatiana?
5 to the square root of 4 is 1, and then 4 to the square root of 0 is 1, so 4 plus 1 is 6 times 1. You square root the 2 4s to 0, and then,
Square root won't give you 0.
I mean,
To 2s?
you know, the 4 and the 0 to the 0 power.
Oh, 4 to the 0 power.
Yeah, 4
Okay.
to the 0 power is
Is
1.
1. Okay.
And then do the other 4 to 1. So 5 plus 1 is 6 times 5, 1 again is 6.
Okay, alright. That will work. Alright, 1 to go. Just need the -4, and it is possible. You might think about how Michaela got +4, because it could be very helpful. It's not the only way to do it, but it could be helpful. There you go. Alright, that would work. Very nice. So 0 minus 5 will give us -5 plus 1 is -4 times 1. Alright, nice work. Perfect score. Nice job getting the negatives. You guys were finding interesting ways to do that. Alright. If you would please grab your notes, and we're going to start in on 7.1b. You can either start a fresh page as always, or you can draw a line, pick up where you left off yesterday, your choice. We'll eventually add this information to your green booklet, but not today. Yesterday we talked about the multiplication property of exponents. Today we're going to talk about the division property of exponents. And tomorrow we'll kind of do both together. Some problems that involve both of those properties. This is probably a little more difficult than yesterday's, but I think if you pay attention, you do the examples, you guys will be just fine. The main thing we'll have to be a little bit more careful on today are possibly our negatives and positives. So make sure that you're checking your work with a calculator if you need to, or just being cautious, okay? All right, just to remind us of what we did yesterday, let's go ahead and remember that yesterday, you can write this down again if you want, we talked about the multiplication property. And what did we do with the exponents when we were multiplying? Add them. So just x to the a plus b. Alright, that's the multiplication property. So for our division property, what do you think we might do with the exponents? Subtract. Kind of just what you would think. So if multiplying causes you to add the exponents, division is going to cause you to subtract the exponents. And we're going to write division in the form of a fraction. Don't let that bother you. It's just a little clearer way to look at that. Okay? Alright, let's look at a few example problems. And again, like we did yesterday, we'll start off fairly simple. We'll add things on as we go to make sure that we cover all the little aspects that might come up along the way. So let's just start with what should be a pretty simple one. Let's do x to the 8th divided by x to the 3rd. Alright, that should give us x to the 5th. Very nice. So 8 minus 3 just gives you 5. No problem. Okay? We're going to continue that, but we'll, again, add things in. So number 2, let's do x to the 4th, y to the 10th, divided by x to the 2nd, y to the 3rd. So subtracting, keeping x's together, y's together, we get x to the 2nd, y to the 7th. Very nice. Okay. Let's look at, actually I'm going to go to it. Let's do x to the negative 4th, y to the 3rd, divided by x to the 2nd, y to the 5th. Now be very careful on your subtraction, okay? Let's see how we did on this one. See if our subtraction skills are still pretty good. Negative 4 minus 2 is? Negative 6. Awesome. And 3 minus 5 is? Negative 2. Good work. Okay. As we get into more of the negatives, we always want to make sure that we're being really careful. All right, let's do x, y to the 3rd divided by x to the 5th, y to the negative 2nd. Alright, to start with, what exponent do we have with this x? 1. Alright, so 1 minus 5 gives us negative 4. We want to be really careful on this one. What's 3 minus negative 2? 5. Awesome. Alright, remember that when you subtract a negative, it becomes like a plus. So if you've got a situation like this really becomes 3 plus 2, because we have 3 minus negative 2. If it helps you to write it out, you can also use, similar to when we were finding slope, If it helps you, you can set yourself up something like that, and then plug in 3 and -2 and make sure that you get it punched in correctly. Alright, if that helps. If you don't need to do that, then obviously you don't need to do that. Alright, let's look at number 5. What if we have something like this? Let's say we have x to the 3rd, z to the 10th, divided by x to the 4th, y to the 7th, z to the 2nd. What looks like it could be an issue here? What's different about this one? Yeah, we only have the one y down here. We don't have a y up here to pair it with. Okay, so let's go ahead and do our x and our z, and then we'll talk about the y. So 3 minus 4 would give us -1. We'll go ahead and do the z. 10 minus 2 is 8. Yep, positive 8. And let's go ahead and put a y up here. What exponent would it have?
0.
0. 1 was a good guess, but remember, y to the first means that we have a y. In this case, we don't have any y, so we're saying y to the 0 power. So then what is 0 minus 7? 0 minus 7? -7. There you go. So whenever you're missing a piece, whether it's on the top or the bottom, with multiplication it wasn't that big a deal. With division it is, because we need to make sure we're subtracting accurately. So if you're missing a piece, put in that variable to the 0 power. Okay? So try one similar to that down here. Let's do a to the 4th, b to the 2nd, divided by a to the 7th, b to the 7th, c to the 7th. Seeing a lot of right answers, so that's good. Okay, first thing I noticed before I even start is I noticed that I'm missing my c, so I'm going to go ahead and put in c to the 0. Some of you didn't write it in. As long as you're being accurate, just be careful, okay? It's easy to forget as you're going along. So I would suggest writing it in, but you know, you'll make that choice for yourself. All right, a to the -3. B to the -5, C to the -7. Lots of negatives on there. Alright, nice work. Okay, really only one other thing that we need to add in, and that is, what if we have some whole numbers involved? So let's say we have 10 x to the 4th, y to the 3rd, divided by 2 x to the 5th, y to the 7th. We talked a little bit about this yesterday, that we subtract the exponents, but what do you think we would do with the whole numbers? Divide them. Awesome. So 10 divided by 2 is going to give us 5. Okay, just like we did with multiplication yesterday. You're really just simplifying that fraction. All right, we'll finish this one out together. 4 minus 5 is -1. 3 minus 7 is -4. Alright, try number 8. Yes, ma'am.
But there ever be ones like it'll come out to a decimal?
We're going to get to that. So hold that thought, because yes, you're right. Now you can't always divide that out, and we'll have to have a plan for that. So we will get to one of those in a moment, so we'll answer that question in just a bit. Alright, let's do 32 x to the 3rd divided by 8x y to the 4th. Places you can start here. You could go ahead and start with your division, but you might also, before you're, when you get into some that are a little more complex, you want to look over the entire problem before you start, moving things around, start subtracting, start dividing. And one thing I noticed right away is I always kind of look for matching things. I have a number on top and bottom, I have an X on top and bottom, oh, I'm missing a Y. So I like to get that filled in before I even start so I don't forget later, okay? You might just kind of start the problem and then see it. That's okay too. But if you kind of keep a plan in your mind of how you're going to do each problem, that might be a good idea. Just so that if you're following the same pattern each time, you're less likely to forget something. Okay? All right, 32 divided by 8 is 4. All right, x to the second, y to the negative 4. 3 minus 1?
Oh.
Yeah. Yep. Okay. Remember, if the variable's there, and this is something that can be tricky, so let's take a minute to look at that for just a second. If the variable is already there, then it gets an exponent of 1. If you're writing it in, like it doesn't exist at all, then it gets an exponent of 0. Okay, so if the variable's there, that means we have 1. If it's not there, we've got to put in an exponent of 0. All right, let's go to the question that Tatiana had a minute ago. What if you can't divide something? Or what if it would come out to be a decimal if you divided it? And we're actually going to have a really simple solution for that. So let's go with 2 x to the 5th, y to the 6th, divided by 3 x to the 4th, y to the 7th. Okay, again, I'm going to kind of just double check some things. So first of all, I see I've got a couple of numbers, I've got my x's, I've got both y's. So I don't have to fill anything in, so that's good. Can I take 2 divided by 3 and get a whole number? No. Similar to when we're putting things in slope-intercept form, we're just going to leave it as a fraction. So we're just going to leave it 2/3. That kind of makes that part a little bit simpler. All right, 5 minus 4 is going to give us 1, and 6 minus 7, negative 1. Okay, so if it doesn't divide out easily, just leave your fraction. All right, just a few more examples, and then I think we'll have everything. I'm just trying to hit all those little things that can come up on occasion, so that if they happen later, it won't cause you to panic. All right, let's say we've got 11 x to the negative 3rd, y to the 4th, over 7 x to the negative 2nd, y to the negative 1st. Subtract carefully, please. Do a quick check. I've got 2 numbers. I've got both variables matching up, so I'm ready to start simplifying. Can we take 11 divided by 7? No, not super easily, so we'll just leave that. Alright, let's see how we did on our subtraction. -3 minus -2. -1. Nice job. And 4 minus -1. 5. Awesome. Okay. Let's look at number 11. Throw in one more kind of different thing just to see how we handle it. Okay. Let's say we have x to the 4th, y to the -2nd, over 5 x to the 7th, y to the -3rd. Now, the first thing I notice is that although I have both of my x's and both of my y's, I don't have both of my numbers. So the question is, what do I fill in up here? Is it going to be 0 or 1? 1. Because you got to think about the fact that these are all multiplied together. If I multiply by 0, what's going to happen? What happens when you multiply by 0? It's 0. It would cancel everything out. What happens if you multiply by 1? Yeah, it just stays the same, right? So we can always multiply by 1 without changing anything. Alright, so can we take 1 divided by 5?
No.
Now let's just leave that a fraction. I mean, we can, but it's not going to be pretty. Alright, 4 minus 7, -3. And -2 minus -3, 1. And of course, with that 1, you can write it in there or leave it out, your choice. Alright, last one. Alright, this is going to give a little bit of everything, so let's see how everybody does. Alright, let's do x to the 3rd over 7 x to the 7th, y to the -4th. Lots of gaps to fill in there, so be careful as you do that. Let's check our lineup here. We've got, I see x's paired up, but I'm missing some other things, okay? What can I put in to match up with my 7? 1. Okay, because multiplying times 1 doesn't change anything. And y to the 0. Awesome. Alright, so we got 1 over 7. 3 minus 7 is -4. And be careful on this last one. What's 0 minus -4? Positive 4. Good. Okay. I think if you stop and kind of check the lineup, as I would call it, make sure that you have something top and bottom to match up before you start, I think you're going to be pretty successful. You guys did a great job on this. Be careful on the subtraction with negatives. That's the only thing that sometimes causes some grief. But I think you're going to do quite well. Alright? You can set that aside, or if you want to leave it out while you work, you may do that too. And we'll get a practice going. Again, a little bit of a longer one today. We'll see how much of it we get through. I'm not sure if we'll have time to do all 30. But please check your answers carefully. Make sure you're looking especially close at your exponents so you'll know if you have positives, negatives, right, and all that good stuff. Again, we're going to add to this tomorrow, so we need to be experts at this part before we add to it tomorrow.